सर थोडं जोरात बोलावं लागलं.
त्याचं काही बघायचं. So my name is Dr.G.G.Pinagel. I am going to introduce a new topic, that is atomic structure. So first of all, I am going to introduce some definitions about the atomic structure, or it is also called as structure of an atom. So this topic totally depends upon the 118 elements in the periodic table. Periodic table, which contains 118 elements, explains all these facts like atomic number, atomic mass number, and relationship between atomic mass number and atomic number. So first of all, I am going to introduce the first initial important definition, which is asked many times in CT, NEET and board examinations. First of all, that is called atomic number of an element. So this is nothing but number of protons present in the nucleus of an atom. So atomic number is the number which gives a number of protons present in the nucleus of an atom. For example, sodium has an atomic number 11 and atomic mass number 23. So atomic number 11 and atomic mass number 23 is nothing but an element, sodium, which has 11th position in the periodic table. So this, the figure which is placed at the bottom, that is 11 of the symbol of sodium, and at the apex of sodium, the number that is 20 is written at the apex of sodium. So this itself indicates that number, the bottom figure explains atomic number. So atomic number is represented by Z. It means Z is equal to 11. So sodium contains number of electrons present in the nucleus of an atom of sodium is equal to 11. Hence sodium has atomic number is equal to 11. At the same time, the second example, that is aluminium, which has atomic number 13 and atomic mass number 27. Atomic number 13 and atomic mass number 27. The figure which is placed at the bottom of the symbol of aluminium is none other than equal to 13. So as it is placed at the bottom of the periodic table, that bottom of the symbol of aluminium itself indicates that that number gives atomic number of aluminium. It means that atomic number of aluminium is equal to 13. Itself explains or indicates that the nucleus of each and every aluminium atom contains 13 electrons in the nucleus. So in simple words, 11 and 13 are the atomic numbers of sodium and aluminium respectively. Itself, in simple words, we can say the total number of protons present in the nucleus of an atom of an element is called the atomic number of an element. This is the first definition of atomic number. So this atomic number is represented by a block letter Z. Z explains atomic number of an element. This is the second point. Third point, this Z letter is placed at the bottom of the symbol of an element. So these are the three important points regarding the definition and characters of atomic number of an element. The second point, that is atomic mass number of an element. So this atomic mass number of an element is nothing but the summation of protons and neutrons present in the nucleus of an atom. The summation or the sum of protons and neutrons present in the nucleus of an atom is called atomic mass number of an element. So atomic mass number of an element is nothing but summation, sum of protons and neutrons present in the nucleus of an atom of an element. So this summation or the sum of protons and neutrons is also called a nucleon. Nucleon. A word which is used for the sum of proton and neutron is called a nucleon. So in simple words, we can also define this atomic mass number element in simple words. That is, the total number of nucleons present in the nucleus of an atom is called atomic mass number of an element. This is the first definition of atomic mass number of an element. The second point, this figure, which is placed at the apex, which is placed at the top of the symbol of an element. We know the figure which is placed at the bottom of the symbol of an element is called atomic number. But at the same time, atomic mass number is a figure, is a number which is placed at the apex or at the top of the symbol of the periodic table. So this is the second important point regarding atomic mass number of an element. So this atomic mass number is denoted or represented by a block letter A. Atomic mass number is represented by initial letter A. At the same time, atomic number of element is denoted by last letter, 26th letter, that is called Z. So this is atomic number and atomic mass number. But many times a question is asked regarding this atomic mass number and atomic number of element. To calculate number of neutrons present in the nucleus of an atom, these two definitions have much more importance, because atomic number is the number which gives number of protons. At the same time, atomic mass number is the number which gives number of protons and neutrons. It means the figure which is placed at the top of the periodic table, at the top of the symbol of an element, is the sum of both terms, that is protons and neutrons. At the same time, atomic number which is placed at the bottom of the periodic table gives only simply number of protons present in the nucleus of an atom. So subtracting atomic number from atomic mass number, subtracting atomic number from atomic mass number, that is the number of neutrons or neutron number present in the nucleus of an atom of an element is equal to atomic mass number of an element minus atomic number of an element. This is the mathematical statement. Mathematically, number of neutrons, that is in bracket capital N, is equal to A minus Z. So N is equal to A minus Z is the relationship between atomic number and atomic mass number of an element. So atomic mass number of an element is very easily calculated. In case of sodium, we know that atomic mass number of sodium is equal to 23. Atomic mass number of sodium is 23. Atomic number of sodium is 11. So using this formula, number of neutrons is equal to A minus Z. It means that 23 minus 11, N is equal to 12. N is equal to 12. This shows that number of neutrons present in the nucleus of sodium. Nucleus of sodium atom is equal to 12. So number of protons is equal to 11 and number of neutrons is equal to 12. This is the history about the protons and neutron number in case of sodium. At the same time, the second example, that is aluminium, which has an atomic number is equal to 13. It means that N is equal to A minus Z, that is equal to A. Atomic mass number is equal to 27 and atomic number is equal to 13. Therefore, 27 minus 13 is equal to 14. N is equal to 14. So, number of neutrons present in the nucleus of aluminium is equal to 14. Number of protons is equal to 13 and number of neutrons is equal to 14. This is all about the number of protons protons and neutrons in case of aluminium and in case of sodium. This is the introductory important part regarding this topic, that is atomic structure. The second thing about this topic, or second important article about this topic, is nothing but the discovery and the characteristics of protons, neutrons, electrons. So we have to give, or we have to explain the characters of electrons, protons, neutrons and protons. So firstly, initially, the discovery of electron, second, discovery of proton, and third one, discovery of neutron. Discovery and characters. Discovery and characters or characteristics of protons, neutrons and electrons is classified in 5 important types. That is, first one, the name of the scientist. Second one, position. Third one, charge. Fourth one, mass. And fifth one, representation. So in order to introduce, or in order to explain the discovery of all these 3 important atoms, that is electron, proton and neutron. So 5 points are important. Name of the scientist, who is going to discover this particular subatomic particle of an element, electron. Second one, position of electron. Third one, charge on electrons. Fourth one, mass of electron. And fifth one, how electron is represented in taking in examples. So this is 5 important points. So we are going to discuss one by one, that is discovery and characteristics of protons, neutrons and electrons. The first of all, first point, that is characteristics. Characteristics of protons. Characteristics of protons. First point, scientist. Second, position. Third, charge. Fourth, mass. And fifth, representation. Representation. So these are the 5 important points which gives the correct information about the characteristics of protons, neutrons and electrons. So we have to discuss initially, that is, characteristics or special features of protons in regarding these 5 important points. Then the first one, that is discovery of proton, that is, who discovers the subatomic particle like proton. Goldstein is the scientist. Egan Goldstein is the scientist who discovers this particle, subatomic particle of the nucleus, that is James Goldstein. This is the first one. Second, as we mentioned in atomic number and atomic mass number, according to definitions of atomic number and atomic mass number, the total number of protons present in the nucleus of an atom is called atomic number. So this definition shows that position or the venue of proton is in the nucleus of an atom. So if proton is present in the nucleus of an atom, the position of proton is in the nucleus. This is the second point. What is the charge? Charge on proton, we know that atomic number is represented by Z. So charge on the nucleus is positive. We know that the charge on the nucleus is positive. It means that this positive charge is due to presence of proton in the nucleus of an atom. This is explained later on by the scientist Rutherford. So charge on the nucleus is unit. The charge on the nucleus is positive. So protons are present in the nucleus of an atom, and that's why the charge on the proton is unit positive in bracket plus 1 charge. So this is all about charge on the proton. Mass of proton is nothing but 1.0078 atomic mass unit. 1.0078 atomic mass unit. Very, very negligible mass of proton there. So we know that this 1 atomic mass unit is equal to 1.66 into 10 to the power minus 27 kilograms. So 1 atomic mass unit is equal to 1.66 into 10 to the power minus 27 kilograms. This is the value of 1 atomic mass unit. And the mass of proton is 1.0078 atomic mass unit. This explains that proton has a very, 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 very negligible mass. So the mass of proton is equal to 1.0078 atomic mass unit. And finally, representation of proton. Proton is represented by P11, or it is also represented by H11, because the mass of hydrogen atom, who is the first member of periodic table, is hydrogen. So mass of hydrogen and mass of proton is nearly equal to each other, and that's why in accordance of mass equality, proton is represented by P11 as well as H11 also. So these are the 5 important points regarding the characteristics or special features of protons. In simple words, Egan Goldstein discovers a proton. This is the first point. Position of proton is nothing but proton is present in the nucleus of an atom. In case of charge, a proton carries a unit positive, that is plus 1 charge. the mass of proton is very, very negligible, and that is equal to 1.0078 atomic mass unit. And finally, the representation of proton is nothing but it is represented by P11 or H11 because the mass of proton and mass of hydrogen atom are nearly equal to each other. So this is all about the characteristics of protons only. Now we want to discuss the second important subatomic particle of the nucleus. So proton, neutron and electrons are the subatomic particles of the nucleus. So we discussed the first subatomic particles and its characteristics or special features of protons. Second subatomic particle is nothing but called it is neutron. Called neutron. Again, this neutron can be distinguished with proton in the form of 5 important points. So this neutron similarly can be explained on the basis of these 5 important points, that is name of the scientist, discovery, that is discovery of neutron, position of neutron, charge of neutron, mass of neutron, and finally the representation of neutron. Similarly, we define that is atomic mass number of an element, that is the figure which is placed at the apex of the symbol of element, or the figure which is placed at the top of the symbol of an element is called atomic mass number. And theoretically, we define this atomic mass number of an element, that is a sum of protons and neutrons present in the nucleus of an atom. Sum of protons and neutrons present in the nucleus of an atom is called atomic mass number of an element. So atomic mass number is the number which gives summation of protons and neutrons present in the nucleus of an atom. So this study of atomic number, that is the number which contains protons and neutrons. So this is the study about the neutron, or the concept of neutron or the subatomic particle of neutron can be discovered by James Chadwick. James Chadwick explains the characters or special features or discovery of neutron. So neutron can be plotted. James Chadwick is responsible to explain the characters of neutrons only. So James Chadwick discovers the concept or the subatomic particle like neutron which is present in the nucleus of an atom. So neutrons can be discovered by James Chadwick and which are present in the nucleus of an atom. So the position, the second point, the position of a neutron is nothing but as protons are present in the nucleus of an atom, at the same time these neutrons are also present in the nucleus of an atom. So first of all, James Chadwick discovers subatomic particle which is present in the nucleus called neutron. Neutron also present in the nucleus of an atom. So according to the experimental facts done by the scientist Rutherford, that is the experiment of bombardment of alpha particles on thin gold plate. So this experiment which is done by the scientist Rutherford explains three different particles called alpha particle, beta particle and gamma ray. Alpha and beta particles, alpha and beta are called particles because they have some definite amount of mass. At the same time, gamma ray has a very negligible mass as compared to alpha and beta, and that's why it is called a ray, and it is also called a secondary effect of natural radioactivity. Alpha and beta particles are known as the primary effect of natural radioactivity at the same time, and that's why they are called alpha and beta are called particles. At the same time, gamma is called a ray instead of particle because gamma has a very negligible minute mass when compared to proton and neutron, when compared to alpha and beta particles. So the scientist, the charge when this Rutherford, the scientist Rutherford explains the experiment, practical experiment of gold sheet by bombarding this golden plate with the help of strong alpha particles, which are high velocity particles called as projectile. Alpha is called a projectile. Alpha is called a projectile. So when a gold plate which contains a number of gold atoms, which contains a number of nucleus of gold atoms. So whenever these alpha particles are hammered on the gold plate or golden sheet, some particles travels in a straight line path. Travels in a straight line path. It means that such type of particle carries zero charge, or it is also called a neutral particle. So similarly, on the basis of this Rutherford experiment, we can say that the particle which travels in a straight line path, which it means that it cannot be deflected towards any other positive or negative electrode, or cannot deflect towards cathode or anode. It means that whenever when it is deflected towards positive electrode, it means it carries a negative charge, and when it is deflected towards negative electrode, it carries positive charge. But the neutron which travels in a straight line, it means neutrons are neutral in nature. They carry zero charge. So charge on neutron is equal to zero, or neutrons are neutral in nature. Mass of neutron is nearly or similarly identical to mass of proton, but mass of neutron is greater than that of mass of proton. And this mass of neutron is equal to 1.0086 atomic mass. Neutron is slightly heavier as compared to proton, or proton is slightly lighter than neutron. So mass of neutron, which is heavier than proton, that is equal to 1.0086 eV. And representation, neutron is represented by a small letter n, that is N01, and this 0 placed at the bottom represents the charge on the neutron. At the same time, P11, that is the charge placed, or the figure placed at the bottom of symbol or the notification of proton represents proton carrying electric positive charge. So this is all about the proton and neutrons. And the final subatomic particle, that is third one. The finest subatomic particle present in the nucleus of an atom is called an electron. So characteristic of electrons can be also distinguished with protons and neutrons in this following 5 points. So the scientists who discover this electron, the most lighter particle as compared to proton and neutron. J.J. Thomson is the scientist who is responsible to discover this lightest particle as compared to proton and neutron, that is called electron. So this discovery of electron has some important meanings, important introduction, that is all about, that is E by M ratio. E by M ratio. E by M ratio is responsible. E by M ratio is responsible to discover the subatomic particle like electron. So E by M means charge upon mass. Charge upon mass, charge divided by mass, means charge on electron and mass of electron, that is a -1 in the charge, and the mass of electron is 0.000546 atomic mass unit. Charge on the electron and the mass of electron, charge on electron, we know that mass of electron is equal to 0.0005496. Or in simple words, it is also taken for our convenience. There is 0.00055. This is the mass of electron. At the same time, we know that the charge on neutrons, charge on electron is equal to unit negative, that is -1. So this charge of -1 and the mass of electron, that is 0.0005496, this ratio is responsible to discover this lightest particle like electron. So this is all about discovery, and this whole work is done successfully by the scientist J.J. Thomson. So Thomson is responsible to discover electron. So Thomson responsible for electron, Chadwick responsible for proton, Goldstein responsible for proton, and Chadwick is responsible for discovery of neutron. So this is all about discovery of electron. This 4 remaining point, that is position, charge, mass and representation is totally different from proton and electrons. The position, we know that the first common point regarding this proton and neutron is that both proton and neutron are present in the